Today, we're going to talk about evidence-based dentistry. You would have gotten a little bit of it in CLD 800. I talked about evidence-based dentistry, so some of these slides are going to look familiar, but not many of them. Evidence-based dentistry, this you have seen, it's the ability to access, summarize, and then apply information from the literature to day-to-day clinical situations. People who haven't been exposed to evidence-based dentistry tend to think that it's just that pink circle, that it's just scientific evidence, that to be practicing evidence-based dentistry, you must be applying whatever the newest, best evidence is to every clinical situation. And that's not the case. As you can see, the evidence is a big part of it, but it's also your clinical expertise, what you're comfortable doing, and what your knowledge base is, as well as what the patient expectations and needs and desires are. So all three of those come together in the middle for evidence-based dentistry. I like this slide, so I use it all the time. I know you've seen this too at some point in your travels here. If you're a clinician, everything starts and ends with the patient. So the patient comes to you and maybe has a concern or a symptom, or you notice a sign of something, or maybe the patient just saw something on the internet and just wants to ask you about it, brings in an article. If it's something you deal with on a day-to-day basis, then you just have a nice conversation about it. But if it's something that you're not all that familiar with, if you don't do it on a daily basis, or maybe it's something that you knew about back when you were in school 5-10 years ago, but now you haven't stayed up with it, you want to know more before you have that conversation with the patient, then you're going to go to the literature. So you want to take that question, concern, and turn it into an answerable question. By answerable, I mean from the literature, that you can search the literature for the answers. Jessica Hollister, our librarian, is going to be coming in next week, and she'll be talking more specifically about doing the search. So I'm going to just go right down to the bottom part, and this is really the scientific piece. You want to search for the best evidence, and that's the research design, how they got their data. Then you want to evaluate that evidence, and that's the statistics. So I'm going to be focusing on those two aspects, specifically the scientific evidence circle of evidence-based dentistry. Here's the scenario. You're out in practice, you've been out 5 years, and your patient comes in and says, I really want to use an interproximal device so that I can better clean my teeth. I see all this stuff about interproximal devices, but there's so many out there. Help me. How do I decide? Are the nylon bristles better than the rubber ones? Are the rubber ones better than the nylon? Can you recommend one? And let's say that you haven't been following the research. So you haven't stayed up on this. And so you're not comfortable saying, oh, yes, I would use this. You want to find out more information about nylon and rubber bristled interproximal devices before you have that conversation. You want to get the best evidence. This is the evidence pyramid. There are several variations of this. This one focuses on clinical studies, so all human studies. The bottom of the pyramid is all primary research where the researcher is actually collecting data, primary information. The top is secondary research. Systematic reviews is at the very top, and I added scoping reviews because when this pyramid was developed, we didn't talk about scoping reviews so much, but systematic reviews were out there. So both of those are near the top of the pyramid. As you go up the pyramid, you have less risk of bias. That is systematic distortion of either the data that you collect or the interpretation of it. For example, down on the bottom, you have case reports and case series. This is a great way to generate questions. You have a case, you've not seen this kind of thing before, so you document it as you go, and then you say, other people should know about this. I'm going to publish this case or the case series. Case report would be one patient with this situation. Case series would be several. It's not a great research design, though, because you maybe do some treatment and the patient gets better. Is it because of the treatment? Would the patient have gotten better anyway? You don't know because there's no control group. There's nothing that you're comparing it to. It's a good way to generate questions for future research, but it's not a strong research design. The top of the pyramid, Jessica is also going to be talking about systematic reviews next week and scoping reviews. So I'm not going to look at the secondary research today. I'm going to look at primary research, and I'm going to look at the top level, which is randomized controlled trials, which is really the gold standard for primary research designs. What a randomized controlled trial is designed to do is to infer causation. A researcher doing an RCT is trying to establish a cause and effect relationship. The independent variable, the predictor, let's say the treatment, is thought to cause the change in the outcome, the dependent variable. Subjects are randomly assigned to the levels or the groups of the independent variable so that there's no bias in who gets into what group. If you do random assignment, then each subject has the same chance of being in the treatment versus control if we just take a simple design. So in the case of the interproximal devices, a randomized control trial would be saying that the type of interproximal device, rubber or nylon, has an effect on the outcome, like gingivitis, for example, cause and effect. We're going to be looking for randomized controlled trials. The search question, this is a good search question because it's answerable. The framework that was used to develop this search question is something you probably have heard of, PICO. The elements that must be in that search question are the population, who are you studying? And in this case, it's healthy adults. What is the intervention? We'll say that it's the rubber device. Comparison is the nylon device. It doesn't matter which one you put in. You have to have two things that you're comparing. It doesn't matter which one you call intervention and comparison. And then an outcome. And let's say we want to know about plaque and gingivitis. So we're going to search for any randomized controlled trial that looks at a difference between those two devices in controlling plaque and gingivitis in healthy adults. And let's say this is the first thing that pops up. Efficacy of rubber bristles interdental cleaner compared to an interdental brush on dental plaque, gingival bleeding, and gingival abrasion. So you not only have plaque and gingivitis, you also have gingival abrasion. We're going to look at this article. In real life, we would look at all of the articles that answer our question, but this is where we're going to start. We're going to look at this article that looked at these two devices. Now we're going to evaluate it. The primary objective was to compare the devices on gingivitis. That's the main thing they were interested in. But they also wanted to look at plaque and gingival abrasion. They also looked at the patient's perception, the subject's perception of these two devices. Independent variable, what's the predictor? The device, rubber or nylon. Dependent variables, these are their outcomes. The gingivitis, which they measured as the bleeding on marginal probing. Plaque index they used for measuring plaque. They scored each surface that they accessed from 1 to 5 and then averaged them for a plaque score for the whole cleaning device for that individual. And then gingival abrasion was just counting up the number of sites that they were interested in that showed any abrasion. As far as patient perception goes, they had 7 items that the patient responded to using a visual analog scale. Used a lot in pediatrics. So it's basically your perception is in centimeters and millimeters. So it's quantitative. The research design was a 2-treatment parallel split mouth examiner blind RCT. This is what the researcher is saying. This is kind of a mouthful. So split it apart. 2-treatment, rubber, nylon. Parallel means that the devices were used at the same time versus like serial using one device and then using another. Split mouth, this is a great design. And they only use the mandible. So one side is getting the rubber device, the other side is getting the nylon device. Examiner blind means that the person who's taking the clinical measurements doesn't know what interproximal device was used where they're doing the measurements. And beyond that, they also didn't have access to previous examinations. They examined on multiple occasions, so they couldn't look at the past. This is a really nice way to reduce possible bias. This is single blind because the examiner was blinded or masked to the assignment. The ideal design would be that both didn't know, because subjects in a research study tend to want to do well And if they knew that they were in the treatment group or the special group, they might try harder. So ideally, they don't know what device they're using either, but obviously you can tell the difference between nylon and rubber, so you know which one you're using. Couldn't do it in this particular case. And it's a randomized control trial because they're randomly assigned to which side they're going to have the rubber or the nylon. In any research, the two main things that we worry about is bias, the systematic distortion in our collection or interpretation, and confounding. Confounding happens when we don't take something into account, and it might be the reason for the results. So it's another possible explanation for the results outside of our study. So we want to minimize both of these so that we can have confidence, a lot of confidence in our results being due to the things that we're studying. Random assignment and blinding, they help to reduce bias. As far as the confounding, the split mouth design is great because it's the same subject on both sides. This interdental and this interdental in the same mouth. So any biological differences or bruxing, things like that, they're balanced. All research involving human subjects must go through an institutional review board before they can be done. The whole point is to protect the rights of human subjects, including is the risk the subject is being exposed to, is there's the benefits either to the subject or to society outweigh that risk. So they're there to protect the rights of the patient. This study did go through the Medical Ethics Committee, which I assume is their review board. Participants read and signed an informed consent form, and you all know what informed consent means, right? It's not just consent. They have been informed of all of the things going on, and they're consenting to it, and they received a copy so that if they wanted to ask questions, they have information on how to contact the researchers. Also, I thought this was interesting, and I don't even know how they managed to do this, but they said that there was an external study monitor that monitored the clinical research site. So that's kind of interesting too. So like outside eyes observing what they were doing. Subjects had to meet these inclusion criteria. They had to be between 18 and 35, for example, good systemic health, non-smokers, right-handed. You think that's an odd one, but what that does is that it assures that you have a dominant side and a non-dominant side. If you were left-handers and right-handers, you wouldn't know if you're maybe comparing a lot of the one device was on the non-dominant hand or maybe not cleaning as well. So the other way they could have handled this is to ask the person, what is your dominant hand? What do you brush your teeth with? And then assign based on that dominant or non-dominant. So there are fewer confounds by doing this. Exclusion criteria, I wanted to put these all on one thing. There's a lot of inclusion and exclusion criteria. Notice down at the bottom, no dental students, you know too much. You're probably too astute. You do know too much about dental health. Inclusion criteria and exclusion criteria are two sides of the same coin. If inclusion is 18 to 35, outside of that age range is an exclusion criterion. This reduces the number of confounds. If you had smokers, is it because they're smokers that didn't work so well? But it also limits generalizability. Now, I wouldn't say that we wouldn't generalize to left-handers based on the results, but maybe people who are pregnant and lactating, would you generalize to them? No, because you don't know what's going on in the mouth, or those who use an interdental device, it might not be the same response. So fewer confounds, better control over the study parameters, but it limits generalizability. The ideal way to get a sample is through random sampling, which means that every potential subject has a known non-zero chance of being selected. But to do that, you have to have a finite population. You need to be able to enumerate or list all of them so that everybody's on a list, so you pick from them. It would be anybody who's healthy and who meets those criteria, and how do you even find them? So most of the time, research is done with samples of convenience, people that are available that meet the criteria. In this study, they had a database of people that already said they're interested in doing research. And they also posted flyers and advertisements. Now, the problem here, when you don't have random sampling, which every member of the population you're interested in has a known non-zero chance of being included, is that this sample might be biased. If you're generalizing to all healthy adults, you have to think, how might these individuals be different from the general population? And one thing I think about is, if you're yeah, put me in a database, they might be better at maintaining their oral health, or they maybe have a higher oral health IQ, more likely to follow protocols. So there's some things that might limit how much you can generalize to the population of all adults based on how you get your data. The last thing is, how big a sample do you get? When you're doing research, you need to think about this, because you want to be intentional in your sample size. Enough subjects so that you can find a real difference if it's there, and not more than that. Think about even a study with mice or rats. You don't want 50 mice or rats if 20 will do. They did a power analysis. This is the method that's used to find out if there's this much difference between the two devices, we want to see it. How many subjects do we have to get so that we will see that difference? And the answer was 42. They chose 44 subjects into the study to guard against attrition. And I think all 44 finished the study, actually. This is how the study went. The first visit, they were given the device, told how to use it, went off and used it. They came back in 2 weeks later. They did clinical assessments, told them not to brush mandibular teeth for 3 weeks. They came back in 3 weeks, did the clinical assessments again, and instructed to use the device as assigned, and also to brush for 1 minute twice a day. From day 0 to day 21 is the experimental phase, where they're inducing gingivitis. Also, this visit is when they're randomly assigned, because it says instructed to use the devices as assigned. This is when they are randomly assigned to either the rubber one on the right and the nylon on the left, or the other way around, and the treatment phase starts. They have 3 visits under the treatment phase: a week after visit 3, a week after that, and then 2 weeks after that. And at each of those, the clinical measurements are taken again. And on the last visit, they also are asked about their perceptions of the devices. They're given general instructions: brush 2 to 3 hours before their next appointment, and don't eat or drink afterwards. Don't use any other toothbrush or toothpaste except what's provided. Don't use any other interdental device. Use a new rubber cleaner each time, nylon cleaner for 3 days. This is with sure consistency, so they're not confounding factors here, and keeps things in line. They managed adherence by doing a calendar of diary during the whole study. They had a reminder card, text reminders about the protocol and what to, when to brush and when your appointments are. They're weighing the toothpaste at the start and then afterwards. And you're not throwing those devices out. You're putting in a little bag and bringing them back as proof that you've used them. This is a very strong research design. It's got single blinding, very strong inclusion and exclusion criteria, a big list of do's and don'ts, and measures to promote adherence to the protocol and monitoring of that. So now we're going to try to make sense of the statistics. Before we do that, the goal of research is to understand something about a population based on our sample. We're not trying to find out if these 44 people, there's a difference. We want to know in general, if adults in good health, does it make a difference? So we're studying a little sample, but trying to say something about a population. Samples fluctuate. You take a sample today, you get some results, you get another sample, and they're going to vary. So there's fluctuations. What statistics does is to help the researcher to make a decision about what might be going on in the population by basing the decisions on probability. How likely is it to get something over here when there's no real difference? The research questions they had was, they wanted to know if there's a difference between the two devices in these 4 things. You have to turn those into hypotheses in order to do the statistical tests, because the statistical tests are testing hypotheses. The hypothesis would be a precise, testable statement about the results of a study, and it refers to populations. So you're talking about in the population of all healthy adults. There are two types: null hypothesis, statement of no difference or no effect, and the research hypothesis, which says there is an effect or there is a difference. The null and the research hypothesis account for all possible outcomes. So there is either no difference or there is a difference. Behind the scenes, there's a model of all the possible results that they could get when there's no difference. And then they check their results against that model and make a decision. So they're testing against the null hypothesis. So if they reject the null hypothesis, if they see that their results are way different than what you'd expect in the model of the null, they're going to reject the null hypothesis. By rejecting the null hypothesis, they have evidence for their research hypothesis, because there's only two options. You're rejecting the null, you're saying that the research hypothesis is more reasonable. Why statistics is that the null hypothesis is either true or it isn't, and we never know whether it's true or not because we don't have all the data. So decisions based on samples, you have a risk of saying that there's a difference or an effect when there isn't one. Statistics is managing that risk. It'd be helpful to know about different statistical tests, but if you're reading the literature, you'll be able to read through the results section if you know what a significance level and a p-value are. The two things that you need to know. These are all related to statistical probabilities when the null hypothesis is true. At the end of the materials and methods section, you will usually see the test that we used, and we established a significance level of 0.05. The significance level, the researcher sets ahead of time and says, this is the most risk I want to take of saying that there's a difference when there isn't one. 5% is the level you'll see most often. Their maximum allowable risk of saying there's difference when there isn't one. If something can happen less than 5% of the time when there's no difference, they're willing to say, I think there's a difference. Results section, you'll see all the statistics. And along with all of the statistics, you'll see these p-values. P-value is the likelihood of the data. How likely are results like these? How likely are they if the null hypothesis is true? You look at that second one, the p less than 0.001. This tells you that, so there were significant differences among study groups. How likely is it to get a difference like this when there's really no difference if we had the whole population? If we did the experiment 1,000 times, you'd still not expect to see one result like this. Less than 1 in 1,000 times, if you did the study again, would you expect to get results like that when there's no difference? If you look at the last one, though, no significant difference between treatment groups, p equals 0.87. If we did the study 100 times, 87 times, we'd expect to get results like this. How likely is it to get results like this when the null hypothesis is true, when there's no real difference? If the result happens less than the risk to say there's a difference when there isn't one, 5%, they're going to reject the null hypothesis. When they reject the null hypothesis, they say they have a statistically significant result, or sometimes they just say significant. In this context, significant means statistically significant, not likely under this situation. All of these are less than 0.05. The researcher says my significance level is 0.05. If anything can occur less than 5% of the time by chance, I'm going to reject it and say that it's not chance. And then the last one, not significant, the p-value is greater than 0.05. Significance level p-values, they're both probabilities. The researcher sets the significance level ahead of time, looks at the p-value. Is this p-value less than 0.05? Yes, I reject. And I conclude that there's a real effect here. If it's not less than 0.05, I'm not going to reject. Easiest way to remember it, if the p is low, the null must go. So keep the 0.05 in your head. If the p-value is less than 0.05, you reject the null hypothesis, which means you have evidence for your research hypothesis. Research hypotheses, they're looking at mean differences. The research hypothesis is that there is a mean difference in all these. The null hypothesis is that there is not a mean difference. The statistical test that they used was a paired t-test. This is a test looking at two means that are related. You have one quadrant, the other quadrant, so you have a pair of scores for each subject. We know that they used a significance level of 0.05 or 5% because they say p less than 0.05, so the p-value less than 0.05 was considered to be significant. So that's their threshold for rejecting. When we get to the results tables, the first table, they're going to show you the experimental phase. This is before the device has been assigned. So they're labeling it the nylon and the rubber, but it hasn't yet been assigned. So they're doing that retroactively, putting nylon and rubber there because no device has been used. You can see that going from day 0 to day 21, there was an increase in bleeding. This is a percentage of sites that bled. I don't know how they got 104%. That's a big rounding error, I think. But basically, you see that it works. If we look at the results in the treatment phase, I would like to have seen an analysis of change over time, but they didn't do that at all. What they did is at each of the 3 weeks, they just looked to see if there was a difference between the two devices. And now we see the p-values. And the same thing for the experimental phase. They weren't looking to see if that was a significant increase in bleeding. They just looked, is there a difference between the nylon that wasn't nylon yet and the rubber that wasn't rubber yet? We're looking at the treatment phase and we're looking at the p-value. We have a significance level of 0.05. Are any of these statistically significant? I'm going to say yes. So if the p-value is less than 0.05, you have a significant result. This says that there's a statistically significant difference in the proportion of sites that showed bleeding on marginal probing between the two. And so 45% of the sites bled with the nylon and 34% with the rubber. So less bleeding with the rubber. Going on to the plaque index, again, plaque, you're not brushing your teeth, the plaque index goes up. And then if we look at the 3 weeks, there's no difference between the two devices in terms of plaque accumulation. Gingival abrasion, they're not doing anything. So the abrasion goes down, actually, between the beginning and the end of the 3 weeks of doing nothing. Then when you look at the 3 weeks of the treatment phase, there's a difference at all 3 time points, and in all 3 time points, there's less abrasion with the rubber device than with the nylon. If you notice, the abrasion goes up every single time, but they're not studying that. So they didn't do any test. Is that a variation or fluctuation that you would expect just by chance, or is there a statistically significant increase in abrasion over time? We'll never know. As far as the patient perceptions, there were 7 items. 5 of them were statistically significant. You didn't have this in the article. You had to go look at the appendix online. And they all favored the rubber device. The 2 that weren't significant, they had partial support for bleeding on probing, but only at the last time point. No difference for plaque index. And then for gingival abrasion and patient perception, pretty strong evidence in favor of the rubber. Statistical significance, it's an unfortunate choice of words because when we think of significance, we think importance. Doesn't mean important. It just has to do with probability. If it's significant, it's more likely under one condition than on another. That's all it means. It doesn't mean anything about being important or earth-shattering, just statistically. More likely here than there. Clinical and practical significance, though, is like, would it change someone's behavior? Would it change how a clinician treats a patient if there's a statistically significant difference between different treatments? In this case, will it change patient behavior? Is it clinically significant? You have to have statistical significance to be concerned with clinical significance, but it's like a baseline, necessary but not sufficient. The researchers leaned into this because they said that the patient perception is important because the limitation is not in the interdental cleaning method efficacy, but the willingness or motivation of the patient to use the device. So this they felt was particularly important. So they said the split mouth allowed participants to make a deliberate choice because they're doing both. Limitations, you always talk about limitations because no study is perfect. They only looked at one size for both devices. So different sizes might show different results. They only assessed bleeding in a couple of areas, so it might not reflect the true inflammatory state. Not much you can do with number 3. You cannot blind people to the type of device they're using. And they said the study only lasted 9 weeks, so longer follow-up is needed. Actually, the treatment phase only lasted 4 weeks, I think, so a longer study would be good. I also wondered about the shape as a possible confound, because I think the rubber device that they used is more ergonomically going to be easier to curve around the tooth. So meanwhile, if you recall, you had a patient who asked you about rubber and nylon devices. Would you recommend a rubber one? Would you recommend a nylon one? How does this relate to your patient? So we've gotten the scientific evidence which shows less bleeding, gingival abrasion, and similar plaque removal. The patients like it, less perception of gum damage. We don't know about the cost differential. And what about you? Are you comfortable recommending one versus the other? So after you get the scientific evidence, then you're going to be talking to the patient. And no matter what the topic, if it's something, a procedure that you talk about whether that procedure is you're comfortable, that's where you have that conversation. Going back to the starts and ends with patient, what does the patient want in this situation and what are you comfortable recommending? And that, in a nutshell, is evidence-based dentistry.